Good morning. My name is Natasha Alia, and this is group one, and our project is about a semantic aware data aware broadcast community-based surveillance agent. So, the content of the presentation, and I'll go straight to the background and its introduction. So basically, this work focuses on improving disease surveillance in Uganda by transforming community-reported data into meaningful, structured, and actionable insights using semantic technologies and AI. Our work is built on 4 forces. First is the semantic data warehouse, which goes with traditional storage by attaching meaning to data. And then second is the crowdsourced surveillance, where community members contribute health data using mobile devices, helping to bridge reporting gaps. Third, and the knowledge graph, which model relationships between systems, diseases, and locations using medical standards like the World Health Organization ontology. And finally, is the neurosymbolic AI, which combines the planning for image analysis with symbolic reasoning for clinical understanding. Yeah, so these are some of the related works that we were able to get. These are some of the because of time, I won't go through each. I'll go straight to the problem statement. So the main problem is that community health data is often unstructured and noisy, making it difficult to use for decision making. The existing systems cannot properly interpret images and system descriptions into medically valid information. Additionally, traditional database models lack the ability to represent complex relationships in health data. So this creates a gap between the community reports and the actionable public health insights. Actually, for the computational problem, we lack the semantic capacity to model complex biological relationships. So that's why in our project, we are going to use an 8-layer locator framework to handle multimodal data. What are some of our research questions when you were coming up with this project? What are some of our research questions? So we asked ourselves, how can semantic architecture improve reliability? How can ontologies reduce ambiguity in data? And how can AI bridge perception and reasoning? So our objectives finally were to develop a semantic wire data warehouse, to build an automated ingestion pipeline, implement a neurosymbolic classification model, and also evaluate system performance using robust validation methods. Our research contribution is that we shall map the surveillance to the 8-layer locator framework. We shall develop an estimatic trust model to validate the data. And we shall also create an extending ontology aligned with the World Health Organization standards and ensure privacy through some of the technical things like case anonymity. So this is methodology and our system architecture, as I talked about it. We are going to use an 8-layer locator framework. And our system is going to flow through this pipeline-based architecture where the data flows from the community sources through multiple stages, including ingestion, semantic processing, evidently, storage, and visualization. So each component is designed to handle low-resource environments, ensuring the system works with poor connectivity. Yeah. So our dataset description, we use the mpox skin lesion dataset, which contains images of diseases such as monkeypox, chickenpox, measles, and others. We're able to get this dataset from Couple. It is a bit large. It gives us different variations, though the dataset is a bit unbalanced, with some clusters having fewer samples and others having more. It contains variations in lighting and image quality, and includes reviews of similar, making classification a bit challenging. So what did we do? We address this using data augmentation techniques such as rotation, clipping, and brightness adjustment to improve the model robustness. This is what I was thinking about. The visualization, that's how we saw what was happening to our data set. Some images are a bit similar or they are fitted. And we were even able to see the distribution of the classes of our data set. You can see the chicken pox, the healthy ones are few, and then the monkeypox are many. There are some variations that we're going to be working. We're also able to put a chart that shows the number of images that we have in each class. We're also able to see, as you can see, we did the data augmentation to see the original images of the healthy ones when it was horizontally flipped, vertically flipped, when it's rotated, and even when it's bright. This helped us to have a view of what is happening to our data set. So basically that is it. I'll call my colleague to continue from where I've stopped. Thank you so much.
Okay, good morning. So I'll continue from where my colleague has stopped. So here we have the model selection and deployment. Well, we have the ETL and data cleaning, which ingests community reports and cleans data, the semantic harmonization, which standardizes the local descriptions to structured format. So like what I mean by that is that overall the model deployment pipeline, this one will be moving from decentralized mobile ingestion through an large language model assisted harmonization layer into the semantic data warehouse. So this one ensures that the business intelligence dashboards provide actionable, verified insights for public health decision makers. Yeah, as you can see here, we have the community data sources to decentralized ingestion, then to semantic harmonization, to data warehouse, to BI dashboards, then to the end users. Yeah. So going on to the next slide. Here we have the demonstration of the developed products. So I'm going to play and you see how it looks like. So basically this, as you can see, we have the surveillance dashboard, then the live capture if you want, then the knowledge graph view of the data, which you've already inserted in from like the capturing of pictures. Yes. So then here we also have, so here our primary IP assets include the standardized exam observation ontology, like as my colleague had said earlier on in the 8th layer, the automated ETL scripts for semantic cleaning, and the deployment documentation for the 8th layer architecture. Yes. As you can see here, we have the dashboards and BI reports, data augmentation pipeline, techniques for expanding, and so on. Yes. So going on to the next slide, we shall have the limitations for the architecture failure mode. So truth be told, you can't be sure that a product will work 100%. So here we have edge latency, where by processing multimodal data at mobile edge can be slow on a low-end devices. Then the semantic overload, where we have complex ontologies, which can increase query response times in the gold layer. Yeah. Then the other limitations for data and system, we have data sparsity, whereby we have like low report volume in remote districts, which limits spatial prediction. Then also the large language model hallucinations, where there is a risk of incorrect entity extraction during the semantic annotation phase. So some of the suggestions to these limitations, we address this by proposing tiny machine learning quantization for the edge and schema constraint generation to force AI outputs into the medical ontology. Yes. So the other suggestion to the limitation of hallucination, here we can use the schema constraint generation to force LLM outputs into the clinical ontology. Yes. Then also latents, where we implement knowledge distillation to deploy quantized models. Yes, via the tiny machine learning. That's what I meant. So going on to the next slide, we shall be having the conclusions and the feature works. So in conclusion, basically this work proves that the data warehouse must evolve from a passive reporting tool into an active semantic knowledge platform. Yes, whereby it will be reconceptualizing the role of the data warehouse, like as an epidemic surveillance system, as we saw earlier on the demonstration part. Yes, so some of the feature works here we have it will explore the federated learning to further enhance like privacy across the Uganda's districts, in that to keep the content safe and sound with no corrupting any data. Yes. So the next of the feature works here we have the development of localized small language models for offline fast ingestion. Yes. So going on to the next slide, we shall be having the references, as you can see them there. So here we have strictly followed the IEE formatting. Yes, for our citations. Yes, as you can see, these are some of them that we used. So going on to the next slide, we shall be having the acknowledgements, whereby we thank our lecturer for the guidance on semantic architectures, Mr. Galiwango, and the open source community for the data used in this research. Yes, then also we appreciate the School of Computing and Informatics Technology for providing the facilities instrumental in conducting this research, and also gratitude to the open source community on Cargo for providing data sets used to simulate the surveillance system, and special thanks to the village health teams in Uganda for the inspiration to conduct this research, addressing the real public health challenges. So yeah, thank you so much. This is CS1, and this is all we had for you. Yes, thank you.